Hello. The following example is example 6 in section 1.5. This is pretty much the exact same example that we just did. The only thing that has changed is the actual question. The question says, how long will it take for the projectile to return to the ground? The question is, what is the height at ground level? Well, I'm going to go ahead and draw the picture again. Here's time, and here's height. Here was the picture we drew, and this was 50 feet. That's what we just got through doing. However, the height being 0 is where the ground is. So we're going to get two different solutions here. So S is 0 for the ground. That means 0 is equal to negative 16t squared plus 100t. I need to solve this equation. Now I could add 16t squared, subtract 100t, and use the quadratic formula. However, I'm not going to do that. The reason I'm not going to do that is because notice there's a common factor of t in these two. So that gives me 0 is equal to t times negative 16t plus 100. I realize there's another factor besides t, but I don't really care. The reason I don't care is because what I can do is I can now use the zero factor property. That means t equals 0 or negative 16t plus 100 is equal to 0. Over here I'm already solved. Over here, subtract 100. So it gives me negative 16t is equal to negative 100, and divide by negative 16. That gives me t is equal to negative 100 over negative 16, so that's a positive number. The question is, what's in common between the two? Well, the greatest common factor between the two is 4. So 100 divided by 4 is 25, and 16 divided by 4 is 4. I'm going to go ahead and write this as 6.25. That's how many seconds it will take. Now, 0 and 6.25 are the two solutions I got. 0 is what's happening right here, and 6.25 is what's happening right here. How long will it take for the projectile to return to the ground? I have to reject 0, because this is not returning to the ground, this is leaving the ground. We're going this direction. So returning to the ground happens over here at the 6.25. So it returns to the ground after 6.25 seconds.